program that we started to give to our customers, our engineers, and we really want to show you that and showcase what the engineers have done and are doing currently. So it's really cool there. We're also going to start the live demonstration with a B19RG and a B19RG extended. So as I get started here, we've got the B19RG. You'll see this precision air regulator on the back, and you'll want to go ahead and set that pressure. You can see it's rising. If I let it go, it's counterbalance to take all of the weight. It has the ability to take up to 25 pounds of counterbalance weight. So we'll tune that in there. As I always like to say, just get your dialed in. There we go. So we get that dialed in, and the cool thing about this, as I come at the camera, you'll see you have 56 inches of linear reach outward. So that's pretty cool. You also have the ability to get about 20 inches of vertical stroke on the up and down. But the nice thing that comes is the free range of motion. You have about 6 rotations, one here at the base, at the top of the angle, coming down on the parallel arms, out on the extension, on the drop down, here, and then the tilt and the rotation on the mounts and the tools axis right there. So this is a pretty unique application. We've gone through a lot of revisions to get to where we are today. So it's really cool. And the ability to take 4 standard gimbal mounts here, and what I mean by the gimbal, this is what you order when we say I want a gimbal here for the B19RG. The B19RG is the arm itself. There are 4 different sizes. It goes from 0 all the way up to 5 3/8. So just let us know what grinder you're using, because we have a big library of the ones that we use. Just let us know. I'm going to hand it over to Kyler. He's going to go over the B19RG extended now.
Yeah, thanks, Jeff. So B19 extended here is basically just as it sounds. It's a has more reach than the arm Jeff just showed, and the reason we did that, we had a customer who was grinding boxes that were like 30 inches tall. The B19 has 20 inches vertical stroke. So if you see here, once I set that counterbalance, we go side by side. This one has 35 inches of vertical stroke. So extending those arms, and then the stroke of the cylinders, that gives us the ability to move that 35 inches up and down. It also, then the linear reach on the arm is 75 inches. So that was the thought behind this one. You can see in the arm we're using 2 cylinders to counterbalance the weight, and this one can also go up to 25 pounds. This gimbal mount is a little different than the one Jeff was showing. This is a vertical grinder, so we are putting our mount in between the head of the tool and the handle, still allowing air to run through the tool and giving it the ability to rotate on that axis as needed. Just to recap, with these 2 arms, with these 2 solutions, the main purpose for them was to reduce fatigue and possible injury to whoever's using that grinder from repetitive movement. Another advantage of it is the tool that you're using. You might be able to use a bigger grinder now that you don't have to worry about carrying the weight, which could then increase or reduce the amount of time it takes to get the job.
Yeah, let's be honest about this. Kind of work out about every day. I work out about every 5 years. So to be able to lift that, the vertical grinder, what he's talking about, and even the 7 to 9 inch grinder that we had on the B19RG, I can't hold that steady for an extended period of time. And that moment when you take that out away from your arm, anytime you extend out and you're holding weight like this, it's like doing a shoulder workout of your life. Okay, people are doing this for their life. This is their livelihood. So we're giving them the opportunity to work like this, stay in that ergonomic rotation, and allow them to extend with weightless effort as they kind of dance through the day. So it's kind of a cool thing. So actually we're going to transition now into the computer portion of it. We're going to pull up our AutoCAD viewer. Kyler's really going to take over and really dive into how we do what we do. We do it through meetings, we do it through data application sheets. So as we slowly span over here to what we've got on the TV, I'm going to be pointing out, different things that we have here while Kyler interacts through the screen and kind of demonstrates basically what he's done and why he's done what he did.
Yeah, so let's start out with some part manipulator applications up here. So for this specific one, we have our PM22A model arm, which is the actual lifting manipulator arm that I'm highlighting there. And then we have a custom end effector that utilizes a pneumatic gripper that we designed specifically for this customer. So the application itself, we are picking up 6 different parts, and parts weigh anywhere from 50 to 90 pounds. This gripper.
Video quality is good. Video is fine. It's just the audio is shit.
So what Kyler has down here at the bottom, when you get to your viewer and your link, we're going to give you the ability to rotate 360 degrees, pan in on what you want to do in that center screen, the ability to zoom in and out, and we're also going to give you the ability to explode, to do some basic measurements, so that way you can see whether it works in your station, give you that high interaction that we want you to have, so that you know whether or not the investment is worth it. We know it is, but we want to give that tool to you so that you have that at your fingertips, really. But go ahead, yep.
Yeah. So we're grabbing on the IP of 6 different parts. So this arm here, the gripper moves it in and out to provide that clamp force. This is a stationary arm. These pads here are all made of UHMW, so our contact points are all made of that softer UHMW so that we don't maul or damage any of the parts, which is a common thing, either some sort of UHMW or rubber is a common thing that we use when we're contacting parts to make sure we don't damage them. Along with that, the controls for this gripper are right here. So it's a 2-hand operation. The pneumatic button or a neutral button, is on the right, and then open close levers are on the left side. So you hold one down, and then hit your open and close. You have both hands out of the way, making sure that you're not pushing a finger or causing any harm. Another added safety feature that we have on this particular end effector is an anti-drop feature, which is basically making it so you can't release the part until you set it down on something. So
maybe if you explode that to show.
Yeah, I'll explode that. So you can see in the vertical rotation up here.
So we're really putting Tyler's skills at computer, to the test here. He's working on a desktop and passing it to a big screen.
My 3D modeling software. It is a little bit different at first, but there's a button down here, and once you set that part down on a hard surface, this shaft will slide up a little bit in those bearings. Pressing that button, and then that will allow your circuit to then actually release the gripper, making sure that you're over a hard surface and you're not just going to drop it on someone's foot or something that's why you're carrying it through the air.
So the cool thing with that is really, and that was a very, very specific safety feature that we were requested to do. Not everyone has at that level, depending on the corporation that you're working for, the job that you've got, that you're looking at finding a solution for. Not everyone needs a 2-handed operation or a safety switch to, disengage, because they don't have that many operators around them while they're moving said part 60 to 90 pounds. So you don't have to get it with that if you don't want to, but it is very easily added if you need it. Just tell us up front.
The main problem that we were solving for them in this application was the weight. So 60 to 90 pounds, they were implementing they had buddy lift procedures across their plant where if I think the part weighed over 40 pounds, then they either needed a manual lift assist like this, or a second person there to lift it from the different places. So this eliminates that two-person operation and makes it easily accomplished and quickly accomplished by one.
Awesome. Yeah, absolutely. And please keep in mind, we want you to ask questions. So if there are questions, please let us know. We can always come back to something. We've got Tiffany behind the camera line, and Nick behind 2 and 3 operating both questions on those platforms. So please let us know what you need, and we'll come back and we can always revisit. But yeah, Kyle, if you want to pull up the next one,
Yeah.
we'll talk about the next one being, it's so awesome to be able to offer this to you guys live, both in this setting and also in a more intimate setting, more one-on-one, or training, or whatever you need. You can see that the facility that we have now here in Wapakoneta, Ohio, has the ability to stream, to do live meetings, to do whatever you need, so that you don't have to spend hundreds of dollars to travel somewhere. Yes, let's spend hundreds of dollars to make sure that 20,000 is worth it. That's what I say. Do a live interaction video with us. Let us help you present this to a customer or to yourself and to your bosses out there. Let us know what you need. Go ahead, Kyle. What do we have here?
So this upgrade features the PM33A model arm, which what that means, the PM33A. So PM stands for part manipulator. That first number that you hear is the length of these parallel arms. So 3, that's a 3-foot parallel arm here, and then that second number is the length of the angle. So this is also 3 foot. That's where the PM33A comes from. A means angles, and it was straight across here. There's the PM33S. Just to give you an idea, when we talk about these moving forward, what we're talking about.
So why would we want to pick an angled arm versus a straight arm in an application?
Yeah, it just depends on your workstation and kind of where you want to go. If you have cables or obstructions close to where you're mounting the arm, then the angle helps you get up over that.
Gotcha.
And that's one of the advantages there.
So keep in mind, the arms that we have today that we're talking about, they go up to 200 pounds. This specific one goes to 150 pounds. Gives you roughly 16 to 89 inches of linear reach and about 38 inches of vertical stroke up and down. So yeah, go ahead, dive into that the end effector here.
Okay, so this was for an industrial fan manufacturer. So they were assembling fans by picking up motors weighing up to 50 pounds and then putting it on the frame of the fan, and then bolting it down and getting it all ready to go down the line. So what this does is it lifts the motor from the pallet to that frame of the fan. So we do that by gripping around the round motors with this wide V design. There's a wide range. I think about 3.5 or so to 6 inches in diameter motors, the different motors that they were loading.
So this isn't one part specific here?
No, this they had a couple different models, I think 5 or 6 different models of motors, and this was able to accept all of those and link them.
That's awesome.
The open and close is a lot simpler than the last solution. It's just a simple lever, basically like an on-off switch where the gripper's all the way closed or the gripper's all the way open. The arm, as always, is controlled by this joystick.
Tyler, if you want to put like the paddle switches you had earlier,
Yeah.
Did you want to put paddle switches on that up and down?
So that's not something we typically recommend with for controlling the motion of the arm.
Okay.
The nice thing about that joystick is you can kind of feather it, so it doesn't have to be all the way on, all the way off like those
Gotcha.
paddle levers are. You can control your speed a little better. You can go faster when you want to. Then if you're getting close to the surface, you can back off a little bit and slow it down.
It's kind of like playing like PlayStation or Xbox. When you throw that toggle forward, you really go hard forward and then backwards. Ah, cool. All right. Yeah, sorry, keep going.
No, I mean, I think that pretty much covers this one. The big thing here is we're eliminating that fatigue of loading those 50-pound motors at basically head height. So you're lifting that.
Oh, so you're like right,
up
you're lifting a 30-pound part right here.
And
Okay.
You're doing that all day long. We're eliminating that fatigue, giving them the ability to focus on the actual process and the quality of what they're doing rather than being sore or
Right.
just dead tired. So
Perfect. Well, hey, while Tyler pulls that one up, keep in mind, the reason that we have our engineered solutions here today, and even in the future, you got to think about safety of your operators. There's not as many operators in factories as there once was, so that's a big key factor, and making sure that the operators that you do have stay safe, stay healthy, and keep in mind, what's the average cost of a surgery? I don't know. I had that hanging thing from college. My shoulder hurts, like when I rotate it forward. So I couldn't do that motor lifting all day long. If I would tear this in the middle of a motor lift, you're talking 50, 100, not to mention downtime and the time that's spent away for that individual, for the operator, mentally and physically. So just really getting out there and getting ahead of some of these injuries is key, and it's cost effective with what we do here. So go ahead. What arm do we have here, Carly?
yeah, so this one is the PM23A.
Okay.
We have a drop down on the end of the arm
A lot going on in that one.
to a pneumatic gripper. I'll pull up a picture here to give you an idea of where this is going and why it looks like it does. So right here, you can see kind of the area. This is an outline or a 3D model of the workstation that it's at, and it just doesn't have both the walls in there.
So what is this? Is this
That's a tensile tester machine.
okay?
We're helping them load and unload rebar from their tensile tester.
So where Kyler just went to, just for those of you following along with us, we went to flexmachinetools.com. It's our blog page. We have all of these solutions up there. Tiffany, our content writer, has written a ton of stuff. She's on camera one. But yeah, just all of this stuff in detail for you so you can truly understand where the application fits. Where does a part manipulator that has this reach, and the weight capacity of, which one did you say this one was?
PM23.
The PM23, so we're roughly 150 pounds here. Really trying to see how to use them. And you can go back and kind of describe what we've got going on in here as well.
Yeah. So going back to the model. So we created a custom bracket to mount to the wall. Now we did this with the workstation they had because they didn't have a lot of floor space, and so we could mount it up over a table, and the arm can pull up nicely, not taking much of a footprint from the already tight space that they have on the floor.
So that takes into account why we would use like an angle on there.
Correct.
Okay, perfect.
And then, so since we raised it up over a table, we had to then create a drop down on the end of the arm so it would be at the comfortable height to use and where the rebar actually needed to go. So it's pretty low to the floor where it needed to actually go. So
what do we have going on in here? I noticed this is not the orientation that was on the blog page.
yeah, so we have a vertical rotation up here that allows for them to kind of align the gripper fingers where they want to go. And
Okay.
then we also have a horizontal rotation that allows them to flip the part from that vertical orientation that you see it in now to the horizontal one that is important. The reason they're doing that is because when it's presented on the table, you lay it down flat.
Right, on the table it was like this in that trough.
The tensile tester requires you to load it vertically. So,
Gotcha.
ability to do both.
So now you've taken us through a vertical gripper. You've taken us from that horizontal style kind of going around that motor block. And then now we've combined both the vertical and horizontal in the same one with a drop-down extension. So how do you come up with those ideas? Like what goes into that to get all of those in there?
Yeah, I think it just it starts with that information packet that we get filled out.
Yeah.
Yeah.
Okay.
That is huge for us to just get a good picture of what number one, what is your goal? What is the main thing you're trying to accomplish? Or obviously with part manipulators, it's usually lifting weight. But are you trying to improve speed? Are you trying to eliminate an extra user? What's the goal? How can we help? And then from there, just getting the specifics of the application on where does it need to, how far does it need to reach, what's the weight of the part. And we kind of cut our options down and kind of on what we can do, and the best, simplest solution that we can provide is what we look for. Simple is easier to use and works better.
I always like to use the KISS method. Keep it simple, stupid. In reality, that is the key. Over-engineering a solution like this, all it does is it creates extra costs. It creates bulkiness where operators won't use it. And we hear the term, I know Tyler has heard it a lot, I've heard it a lot in ergonomics, get rid of this paperwork. I mean, literally, they have it in a closet because it's so bulky and overdone that people don't use it. So keep that in mind. That's why we come around with solutions that we do. So Kyler, go ahead and hit the next one. Keep going. Again, it's really crucial to remember one thing here. We do a lot of this discovery, you might want to call it, with an app data sheet. It's amazing to be able to take all of this information, most of it done being through emails to our distributors, emails to end users. We're taking it and we're just having a simple conversation, as complicated as a go-to meeting or a Google meeting, whatever it need be. We get a lot of information transferred that way, so you don't have to say, hey, I need you to fly across the country, because we've done a lot of different ones that we have throughout the country, and we haven't flown anywhere. The information was just shared with us, in the right sequence. So which one do we have here, Tyler?
Yeah, so PM33A. Again, the 3-foot front arm, 3-foot angle arm from the back. This is again using a pneumatic gripper to grab onto round and or square tubes. So
wait, you said, did I hear you right? You said round and square? So again, we're incorporating more than one part in the design?
Mm-hmm. It's actually, I believe it's 2 different sections or areas of the same part that they would be able to grab onto. Correctly. So.
Gotcha. In the perfect world, nothing is easy to grab onto when you're talking lifting, and just kind of a small location right there. So that's pretty interesting. So go ahead, keep going.
Again, a similar V design as you've seen in the horizontal gripper one that was grabbing onto the motors for the industrial fan. But this one here is again neuro rubber used on the contact points. This also creates a higher coefficient of friction, so we have a nice good hold on the part.
So why use a V, not more of maybe an oval or a half circle or whatnot?
It gives you a more compact area when you're using different diameters or different shapes. You can kind of encompass it better, and it's not just, it has the 4 contact points instead of you're using some sort of diameter, and the part you're gripping on was actually smaller than that diameter you need it to. They don't have the 2 contact points instead of the 4 that these provide.
Perfect.
This here has a vertical rotation. That's pretty much standard on all our custom manufacturers. That helps you just align the part however you need to, and it doesn't matter where the arm's at.
We'll kind of go over that in an actual part manipulator demonstration. You'll actually get to see it move, and you'll see that rotation. We'll zoom in on that rotation so you can see what's going on there. What do we have right here, Tyler? What's this?
So that's a horizontal pivot point that allows the part to kind of hang off of its center of gravity, so we're not.
So like here, show me here. What are you doing there with that foot?
So if you were holding this, this doesn't really work for the demonstration. There'd be like two different rods here, and you're holding one so it can tilt and be on its center of gravity, because they're assembling this piece into their at their station, and that's kind of how they needed it to be able to line it up and wiggle it in there with a little bit of adjustability.
You notice that when you mentioned that CG or center of gravity, why is that so important to make sure that you put like a swivel there? What's the CG mean for when you're talking about that?
Yeah, so center of gravity, it depends on what we're trying to do. In that last one that was on, let's pull it up again.
So that center of gravity, while he's opening that the one previous, we're talking center of gravity here, and it's not.
So as you can see with this rotation,
so
this will give you a better idea of that. So the rotation axis is through this shaft that runs through the bushing here. The center of gravity of everything that's hanging off of that rotation is right in line with that axis, and that gives it the weightless feel. That,
so you're not fighting
require any force to rotate that. It's a nice, free, easy movement.
So like in this demonstration, if I were to grab the bar here and try to, it naturally always fall like this. But when I grab it here, I can freely rotate it with ease. Okay, perfect. Yeah, awesome.
Okay. Move on to the next one there. Oh, actually, I'll share a little bit more. 85 pounds was the weight on this one.
85 pounds on this one.
Yeah.
Nice.
And then, like I said before, they're using it to put in they're assembling the parts in their station, and so this manipulator arm helps them reduce that fatigue again on lifting the heavy parts. They're needing two people there to have that buddy lift. They could just use the arm and easily and efficiently accomplish that task.
Yeah. Well, what kind of pulls the last one up here? The second to last one. It's key to remember. Where do you put? So the question is, where do you put part manipulator? We get that asked all the time. Well, I want to reach from this side of the station to that side of the station. Everything works in a radius. Kind of move your arm with me out there. So when you're sitting there on your chair watching with me, stick your arm straight out. And what I want you to do is I want you to move your arm in around in a circle like this, and then I want you to rotate your elbow in, and then I want you to lift your shoulder up and down. Okay? So right there is all of the movements of a part manipulator and how it's going to work for you. Whether that's at a table, whether that's picking up from a table, rotating out and into a machine. Those are those things where we really want to know what you're working with and why, because it's so versatile to put it onto a pedestal, to mount it onto something, different things of that nature. We just want to make sure that you understand when we say what your workspace looks like. That's why, because we want you to move up and down and in and out. So go ahead on this one here, the next one. This next one's pretty cool. It's one of my favorites.
Yeah, this one it is a pretty neat one. So we're lifting up the 80-pound discs, and so the neat thing about this one, before they using a FlexArm, these parts are they have a nice finish on them, and it's very important that finish is not damaged at all. So they were using an overhead bridge frame with some sort of fixture that they had to manually tighten on to the part. Now with the arm, it's a simple 2-button switch where, again, that neutral button and open, close, gripper buttons.
So your paddle switches are okay.
Yeah.
So your paddle switches are okay.
This is just for the open and close of the gripper compared to the
Okay.
up-down movement of the arm. So With that hanging by a chain compared to being in this gripper that lets you rotate it about the horizontal axis again.
Did you say they used a chain before?
Yeah, it was hanging by a chain on their fixture, and that was difficult for them because they had to get it into this vertical orientation that you see right here. Also, they needed it flat, and then also for loading on their buffing machine, it had to be at a 20-degree angle from the horizontal plane. So that was tough to do consistently with the chain kind of swinging it the right way and not damaging the fine finish. So
the scrap rate probably is a little higher than you wish.
Yeah, this is helping the quality and that scrap rate and making it a lot easier for the user to move it as needed. So this gripper here, these fingers on the end, they rotate. There's E-tense in there with a spring plunger to kind of gauge where you're at, so you can hit that 20-degree angle and feel it before you close the gripper. You don't have to be worried about lining it exactly up. The V that's used once again here with the UHMW pads.
So that V
kind of grabs that edge of the part where they're okay with contacting, as opposed to any of the faces or the edges where they're trying to protect that surface.
So how many different parts were being used in this one?
This specific one is just one part for this one. The controls on here, we talked about it a little bit, but those open and close, it also has a feature where if you begin to close the gripper and then take your hands off of the controls before the gripper actually grabs onto something, if you take off one button, then the gripper will automatically open back up, so that prevents anyone sticking their hand in there after they hit the button real quick or of that nature. So just a safety measure there that we incorporated.
So that's pretty interesting then. So they've got a two-hand operation again, and then they're using those paddle thumb switches. And then so if I were to release my left hand first, thinking I had it but I didn't, it would automatically, no matter what, just pop right back open. These right here would pop back open. That's pretty crazy. So again, here, I mean, you take a look at what did we solve? We solved the ability to reduce scrap rate. I mean, you're literally not, you're controlling all movements with part manipulator. You're still manual, so you still have that fine feathering and fine touch, both that the joystick up and down, open and close. So the scrap rate went down. Again, shoulder issues leaning in over, a 22-degree, fixture, putting that piece down. So that's a big thing. Again, just efficiency on anchor string and a chain. Let's just talk about that right now. A crane and a chain, literally, to go up and down and in and out and get your rotation. If that's all you have, you completely understand that. The point is, keep that in the back of your mind. Just because you use something large doesn't mean you need to. So let us take a look at that. Let's move on to that last one here.
This one here is a kind of neat one. We have some arrows to show you where all this end effector can rotate and move. But I'll give you kind of background on the application. This is for loading 30-pound parts into a lathe. Now the lathe has a main spindle and a sub spindle. And the process goes, you load the part on the main spindle, close the door, run the machine cycle. During that cycle, the lathe comes over with the sub spindle, grabs the ID of the part, takes it out, and then the machine cycle is done. So the reason that you see two grippers on here, one's a 3-finger eccentric gripper that we're gripping on the ID of the customer's part when loading it into the lathe. The reason we're gripping on the ID in this case is because the fixture in the machine grabs apart on the OD on the main spindle. And there's also some alignment plugs there, so we need to give this ability to rotate about the center axis of that part so they can line up the pins with the holes in the part easily.
That's incredible. So how'd you combat the center of gravity on this one?
Same as last time.
Okay.
So if you look at that horizontal rotation, it is shown right here, basically in the center of that screen, and then we're going right through the center of gravity of the part and gripper then hanging off of this side.
Wow, that's incredible.
So if you picture this main spindle on the left, for loading, as I said before, during the machine cycle, the sub spindle comes over, grabs the part from the main spindle, brings it over to the right side. So then when we're ready to unload the part, that sub spindle is gripping the part on the ID. And then so for the unload, this gripper right here, a little more simple, just a 2-finger B. We're not worried about alignment or anything like that. It's already aligned where it needs to be. We can take it off. We can use this 2-finger gripper as shown. And
awesome.
The controls are nice and close to the gripper. So you have your up and down again, and then the left gripper open close, right gripper open close. And it's a pretty neat application. So 30 pounds may not seem like a lot. Like, you can, most people can probably lift 30 pounds, but this lathe that they're loading, they're having to extend that weight quite a ways out there. So repetitively doing that causes strain in the lower back and the shoulders, those different areas when you're loading that machine for 8 hours a day.
Here you go, a part that we ran on our FlexCNC here. I mean, it's not that heavy, but I mean, literally, right there, I lose my balance. You can see that. Like, it throws my forward lean off. So 30 pounds, I mean, that's an incredible amount of weight. Like I said, I don't work out about it in 5 years.
Looks like you work out, though.
Oh, well, thank you, Nick. But no, seriously, it's incredible to see across the country. That 30 pounds to 50 pounds, it used to be 75 that people were allowed to lift. I know I've been in washed facilities that they're literally telling you, guys, we need to find a solution that doesn't cost $100,000 for 30 pounds and under. Well, again, a bridge crane, a giant swing arm that's holding 1,000 pounds. There's no value there in a small workstation. You lose control when you're swinging a chain from overhead. They have great purposes. We had giant swing arm dips here. We've got a bridge crane here. Use it for the right application. Let Kyler come into your application. You can see that actually as Nick stands around, if you want to stand around with me, take a look at our shop here. Look at this. We've got a ginormous bridge crane that travels the length of our building. And off in the distance, you can see our Gore Bell jib cranes. I mean, we have them, we use them, but we use them, and we try to get people to remember, use the correct part manipulator for the right application. And that's the key thing. So as we talk to Instagram, Facebook, and YouTube, remember the key thing that we do is pick the right application and design it for you specifically, not from a catalog saying you have to pick letter A to go with E and all that other stuff. No, you tell us what you need, and then you get what Kyler does. You get what Kurt does. So now we're going to actually move over, and we're going to do the live demonstration with Kyler on the part manipulator. And this, I will tell you, is crazy. I love this one. We've gotten a lot of things where they need to rotate things from a horizontal to vertical. And just so that you know, that is a heavy plate of steel. That is not a piece of hollow tube that we put on there.
Yeah, this part here weighs 80 pounds. So this is the PM 34S model arm, and so again that S, you can see that the angle back there is straight and not up anymore. So we talked a couple times about the center of gravity and making it easy to rotate when you are gripped on the center of gravity. So this is a little bit different. This is a powered rotation, so we are rotating the part from this flat position, and then we're going to rotate it up 90 degrees, and that's going to be done using this pneumatic cylinder that you see right here. So the arm has a cylinder that provides the lift force. Again, this joystick, like I talked about, you can go up really slow, go up a little faster, and same on the down motion, just depending on feathering that joystick.
How do you adjust the airflow coming in?
Yeah, so all of our part manipulator arms have flow controls on the open and on the up and down, and then same with the gripper and vertical powered rotation as well. So you can adjust that to your preferred settings, where just kind of get a good feel for the speed that you want and are comfortable with, and then set it as such. So we'll go ahead and rotate this up.
So you can see there, kind of show that rotation that we were talking about. That comes standard with all of our.
So the manufacturer, this vertical rotation
so that
here.
vertical rotation there. This is what we were talking about earlier in the PDF or the AutoCAD viewer on the screen. This vertical rotation allows you to align inside of the machine, onto a table, off of a stand, so to speak. And actually we have a stand back here. I'm going to grab that, and we'll show. I can set this stand pretty much anywhere in the working range of the arm itself, and Tyler we can go ahead and align to that.
Rotate the cylinder back down.
So if you're on Facebook and Instagram, bear with us as we rotate the card around to get this. Put
Put it down there and release it as needed.
So kind of talk about what goes into the determining factors of this system for you. How do you keep the center of gravity when you rotate that piece up?
So we aren't actually, and that's why we need that cylinder, because it'd be very difficult to lift if it's not.
Gotcha.
So that cylinder right here for that rotation is providing the force to rotate that part off the center of gravity.
Okay. Well, Nick, Isaac, did we get any questions that anyone had immediately that they wanted responding to?
No, I think that's good, guys.
Well, hey, we really appreciate your time again. We're going to send these videos out. We're going to put them on our blog page, FlexMachineTools.com. Go to the blog. Really take a look at these. Go back. Hammer in between each one of the AutoCAD viewers. If there's no questions, we'll go ahead and I'll start by saying goodbye and thank you so much for your time today.
Yeah, thanks.